Hello Matrix. Now we're going to look at a full question of cams with the included new graphs that we draw in grade 12. Let's read the question on page 104. Okay, so they give the detail of the camshaft and the knife edge. Okay, the specification, rotation, that's important, is anti-clockwise. So remember, when you number, you do the opposite. Okay, so anti-clockwise, that's important. Let me just highlight this. I need to remember. Then it's the graph of the explanation, and then draw the cam and shaft follower, show the arrow indicating direction, draw the displacement graph with horizontal scale. This is important, 30 to 12 millimeters, and vertical 1 to 1. Project and draw the cam profile. Okay, so let's start off. So we're going to start by drawing the given view. Then an arrow. Nine. Remember to put hatching inside the axle, because remember you cut into the profile to see the cam profile. It's usually part of a bigger motor. Then the graph with a wedged edge follower always starts at the bottom here. So that's where it starts. That's where you're going to link the graph. Then I always try to draw the graph as far away as I can, so the profile doesn't overlap it. Now I'm going to draw the graph that we've been practicing. Let's see. So every 12 millimeters equals 50. So 12 parts of 12 millimeters. Here we go. Three, 4, 5, 6, 7, 8, 9, 10, 11, 12. That's 0, 50, 60, 90, 120, 150, 180, 210, 240, 270, 300, 330, and 360. Next scale. 30 degrees equals 12. Then usually I look for the highest possible height by reading the description. So the follower rises 20, another 30, so it's 50 so far, then it's 12, then it's fall, so it's 50. So the highest is 50. Vertical scale 1 to 1, and then displacement graph. Remember, I'm using pen to make it more clear. Please don't use pen. Alright, and now we read the information. So from 0 to 90, the follower rises with uniform velocity. That's a straight line. I just want to check if it starts. Oh yeah, the follower at the lowest position, because the graph doesn't always start at 0. Okay, so you have to read it carefully. Okay. Then from 90 to 150, simple harmonic motion. Okay. So that's 30, so that means it's 15 is half. Then I'm going to number it, so it's 90, 1, I'm lying. So from 90 to 150, yes, it's, wait, sorry, 90 to 150, so now I'm going to take this distance and divide half of it into 3 parts and the other half also into 3 parts. So it's 12. So it's 4. There we go. 4, 8, because 4 times 3 is 12, and that's the distance of between 90 and 120. And so if you divide the circle into 6 parts, you have to divide the harmonic length also into 6 parts. So if you divide 90 and 120 by 3, you get 10. So this is 100. That's 101. This is 130, and this is 140. So it's 100, 110, 120, 130, 140, 150. Okay. Okay, so then 100 and 100. Then say. Then 150 to 120 is dwell. 150 to 210. Then from 2. Then from 2, basically from 210 to 360, it's uniform acceleration and retardation. They put it separately, but it's actually the same. So it's 1, 2, 3, 4, 5. Just gonna check. 1, 2, 3, 4, 5. Okay, so I'm gonna have to divide this up into 2 parts. So I'm going to take between, this is the middle, and then the middle of the middle is there, because it's 6, which is half of 12. And halfway between 270 and 300 is well, it's 30 degrees, it's 15 degrees, so it's 270 plus 15 is 285. Ha! Now take this distance and divide it also into 6. But now it's 50, so that's going to be difficult to do, so let's really see. I'll have to use that fancy-pantsy method. But where? Because this we might collide here. Maybe not. Maybe not. Let's try this. So we'll divide into 6 parts. Any angle that works. So 6 parts. So 60. Okay. Okay. Now I'm going to connect them together. So 1. Oh, wait. I've divided this into 6 parts. But I still need to divide this also into 6 parts. Luckily, the distance is 60, so that makes it easy. So what I'm going to do is I'm just going to make it a bit darker so you can see it. 2, 3, 4, 5. So your divisions and the degrees, they don't have to line up. Okay, that's fine. It doesn't have to. That's what this is also teaching you. It doesn't have to line up. So 1, 2, 3, 4, 5, 6, 7. There we go. 6. Yeah. Hey, there we go. Okay, now to draw the profile itself. Now remember, I take this profile, I'm going to take the maximum distance